Hello, everyone. Welcome to today's webinar. We are going to discuss how you can enable container security on OpenShift with Chef. My name is Kamirat. I'm part of the product marketing team at Progress, and I manage the cloud security product portfolio. I'll be presenting today's webinar with my colleague, Jacob George. He's the product manager for cloud security here at Chef. Right, so let's move on to today's agenda. We'll start with an overview of the OpenShift security platform, what it is, why it's popular, and what the security challenges are. Then we discuss how to secure clusters, and for that, we need to understand OpenShift components and auditing application security. And finally, we learn about implementing security for OpenShift with Chef. We will see how we can perform security scans as part of automated DevSecOps workflows. We've also lined up a demo showing you how all of this actually works. And then we wrap up with a Q&A session. Feel free to type in any questions you may have during the session. We'll answer all your questions at the end of the webinar. All right, so let's begin. Most of us may already know what OpenShift is. It is a cloud-based platform that is used to develop, deploy, and manage container applications. OpenShift was developed by Red Hat. It has an integrated IDE for creating and deploying Docker containers, which can be managed using Kubernetes orchestration platform. OpenShift offers a range of advantages out of the box, from CI/CD pipeline management to built-in security and monitoring capabilities. It also provides multi-tenancy features and even integrated storage. As mentioned in the slide, OpenShift provides Kubernetes management tools to manage underlying nodes and control plane. It increases DevOps productivity as it makes deploying and managing Kubernetes easy and quick. OpenShift speeds up development as it cuts down the effort DevOps teams put into managing Kubernetes. So dev teams can shift their focus on enabling microservices that they need to develop applications faster. And it also streamlines CI/CD processes to improve release velocity. In short, OpenShift, along with Kubernetes, simplifies container stack management. It automates installation and upgrades and speeds up development workflows. To understand OpenShift better, let's look at what the platform is all about, starting with the architecture. Jacob will give us an overview of the OpenShift container platform architecture.
Thanks, Cam. So let's look at the OpenShift container platform architecture. As you can see from the diagram, OpenShift is a layered system. It provides an accurate picture of the underlying Docker formatted container image and Kubernetes concepts, which can be easily used by a developer to build applications. Like, for example, installing Ruby, pushing code, and adding MySQL. Here, the Docker service provides the abstraction for packaging and creating Linux-based container images, while Kubernetes provides the cluster management and orchestrates the containers on multiple hosts. The OpenShift container platform is a microservices-based architecture. It is comprised of simple decoupled units that work together. And all of this runs on top of a Kubernetes cluster with object data maintained in a clustered key value store. The platform services are categorized by function. So there are REST APIs which can be used to access the core object, and controllers which apply changes to other objects and report the status or write back to the object based on the API call. So to alter the system status, users may make requests to the REST API. After reading the user's intended state through the REST API, controllers attempt to synchronize the other components of the system. For example, when a user requests, a build object is created. The build controller launches a process on the cluster to carry out the build after noticing that a new build has been established. The controller changes the build object via the REST API when the build is finished, and the user is then notified that the build is completed. So the OpenShift container platform offers a range of functionality. It enables source code management and deployments for developers. You can manage images at scale within your application. You can manage applications at scale. It enables tracking teams and users across large developer organizations. And it also builds a networking infrastructure to support clusters. Now I'll hand it over to Cam to go through some stats around what the OpenShift adoption has looked like over the years.
Right. So everything that Jacob just explained are reasons that has made OpenShift a popular platform among Kubernetes users. This slide gives a good snapshot of OpenShift's rising popularity. Although the Kubernetes offerings from Amazon and Microsoft continue to dominate, the adoption rate has pretty much been stagnant over the last couple of years. Amazon EKS continues to maintain a 51% hold in the market, while Microsoft AKS saw a slight reduction in usage. In contrast, there's been a steady increase in the adoption of OpenShift. We can see it has gone from 25% in 2020 to almost 37% in 2023. Over the past year, there has been a 5% increase, which is higher than gains made by Google, Rancher, and even IBM Kubernetes offerings in the same period. The spike in adoption is understandable as OpenShift addresses a number of challenges that comes with containerization. The dynamic nature of containers make it very difficult to secure, manage, and maintain. But OpenShift makes it easy to provision containers across different frameworks and databases, and it allows easy scaling and also comes with advanced monitoring capabilities. Now I'll hand this over back to Jacob. He'll explain the security challenges that are faced in OpenShift environments.
Thanks, Cam. So OpenShift by default is a highly secure platform. It enforces some level of security at every level of the cloud native stack. OpenShift provides several built-in security features and enforces best practices to secure containerized applications. However, as it is with most management platforms, security is a shared responsibility, specifically ensuring application security and maintaining compliance. The platform users must implement measures to handle vulnerability management, compliance, and runtime security of the applications deployed using OpenShift. So this means that OpenShift inevitably requires additional security measures to address these security challenges. Some of these security challenges are mentioned on top of the slide. Let's start with the first one, which is misconfigurations. Misconfigurations are very common, especially in scenarios where admins are managing multiple cloud accounts and applications. So misconfigured infrastructure or incorrect security settings within OpenShift can create vulnerabilities within the system. Such mistakes can be costly as it exposes the platform and applications to potential threats. Another security challenge is the insider threat. This creates security risk in mismanagement of user access. It is important to restrict user access and maintain the right user privileges across the platform. Users can easily misuse the access and introduce malicious actors into the system, resulting in security breaches or data leaks. Another security challenge is compliance. So maintaining compliance is a major issue for many organizations. There are regulations like GDPR, HIPAA, and PCI DSS, which have controls which are very specific to the OpenShift environments. So implementing that compliance across your OpenShift environments is also pretty important. So another security challenge that they face is scaling the security. So organizations are continuously scaling, and if they're using OpenShift, they will need to manage the security at scale. And scaling brings in the complexity, which means it is important to have the right tools and processes in place to ensure security scales seamlessly across clusters. For another security challenge, although it may not be mentioned here, is pretty important, which is container image vulnerabilities. Vulnerabilities may exist within container images as a result of outdated software, unsafe code, or improper configurations. Maintaining a safe environment requires making sure that the container images are frequently checked, vulnerabilities are patched, and only trustworthy images are employed. So OpenShift security refers to the set of practices, processes, and tools used to protect Red Hat OpenShift Container Platform from potential threats and vulnerabilities. OpenShift offers several built-in security features and follows best practices to ensure the environment for deploying, managing, and scaling containerized applications. But to ensure continuous compliance and security of OpenShift environments, we can use benchmarks like the CIS benchmarks to continuously audit them. Security tools allow you to continuously detect misconfigurations by running these audits and then address the different elements of an OpenShift environment. Like, for example, the CIS benchmark for OpenShift addresses all different OpenShift elements like the control plane, components, which are like master node, the API server, scheduler service. You can also secure your HCD directory, your controller manager, your scheduler, and your worker node configurations, your control plane configurations, and all the different policies such as your RBAC, service accounts, pod security policies, CNI, and so on. So how do we implement OpenShift security using Chef? So we can leverage Chef's Automate platform to actually integrate your OpenShift environment over there. And after that, you can select your CIS OpenShift benchmark. This is part of InSpec, of course. And after that, you can schedule regular scanning of your OpenShift environments. And every time a scan is performed, you'll be able to see a report which lists down all the controls and which controls are passing, which controls are failing. According to this, you can take remediation actions on top of your OpenShift environment. Now we have a demo video for you. Ashwini from the engineering team is going to showcase how you can scan your OpenShift environment against the CIS OpenShift benchmark.
Good morning, everyone. So today we would be demoing a Red Hat OpenShift container audit profile. So for that, I have created a AWS VM on which the OC installer has been added, and Rosa OpenShift cluster has been created on AWS OpenShift with help of Red Hat OpenShift console. So the VM which I have created on AWS, I have added this credential from once we go to settings, then node credential. I've added its credentials, the SSH file and required username. And then we can move to compliance folder. I have uploaded OpenShift container platform benchmark level 1 and level 2 profile on Automate. As we can see here, it's two profiles are been there with version 1.3.0, which we have implemented recently. And then I have scan job bit. So before scanning a job, I have created one node with adding an IP address of AWS instance, which is currently breachable, and then I can start a scan job. So create a scan job, automate. I've selected the instance. Next, I would select both profiles and next. And see scan. Add it. So it's still running. So to save our time, I have just created one scan job. So I would show the report of the same. So I could go to node 1 and then on the report. So here for control 1.1, it's been saying like API server port specification file should have permission 600 or more restrictive. So we have just checked. So this file permission does not have more restrictive permission as we got as 644, and it should be more restricted like 600 or 300 or 2. So that was the source code. Hence this control got failed. So here we can check like this control 1.1.2 is been passed, as it was said like API server port specification file should have its ownership as root. Expected was root, and we got the same, and hence this control got passed. And check all this control, we required an OC setup to be done, installer with OC login. So it would log into an Rosa AWS OpenShift cluster. And then with help of this command OC get pods, we would able to fetch all the required permissions or instance details. And there are a few controls which we couldn't do or couldn't automate it, so we have added as a manual steps there. Proper one by one steps are been added. This is its source code. Okay, that's all from my side. Thank you.
Thanks, Ashwini. That was a very insightful demo.
We're almost at the end of the session. But before we answer all the questions, I would like to take a minute to give an overview of the Progress Chef product portfolio. Our cloud and container security capabilities are part of a broader DevSecOps portfolio, and this includes the ability to configure, deploy, and manage application infrastructure with the highest degree of security and compliance. We already talked about our scope of coverage, but we see here that our ability to configure, deploy, and manage includes infrastructure as well as applications, with a specific focus on the edge, along with device management for very targeted use cases. Our security and compliance efforts are delivered via Chef Compliance, which provides a single approach for securing different assets, along with the cloud security offering that supports organizations that are deployed in the cloud and are using cloud native technologies like containers. We provide an integrated view of all assets that includes operational visibility using a single control plane or pane of glass. All these value rests on a proven set of trusted tools. You may have heard of these already, like Infra, Inspect, Habitat, Automate, etc., all supported with premium content, which includes out of the box configuration and security helpers for standard environments. The entire product portfolio serves any cloud to any edge. We support application infrastructure that is deployed on any on premise or cloud location while providing deployment and purchasing flexibility that includes on prem, SaaS, and even marketplace options. So this pretty much covers everything that we had for this session. We're going to go ahead and jump right into questions. If you haven't sent in your questions yet, please go ahead and add it to the questions panel. We'll start answering those now.
I think we already have a couple of questions.
Right, Jacob. So I'll read out the first one that we have here. Does Chef work for compliance of OpenShift clusters on on-prem or on cloud?
Yeah, so a short version, it works for both on-prem as well as cloud. But this is because of the way Chef Inspect works. Like Cam explained, there are a bunch of tools which actually supply our security solutions for cloud, and Chef Inspect is the main one here. So Inspect can be deployed on-prem or on top of cloud. It's completely agnostic to the environment. So you can use Chef Inspect not only for checking the compliance state of OpenShift clusters, but any other environment, both on-prem and cloud. It's applicable for a hybrid environment. So yeah.
All right. So actually, one of the attendees wanted to know if this video is available after this meeting. I'll just answer that really quick. Yes, it is. This is being recorded, and you will get an email with the link to the recording soon. Yeah. Yeah, I'm going to the next question. Yeah, so so we saw that, in the demo that Ashwini showed us, I think we use the CIS benchmark, right, Jacob?
Yeah, we did.
Yeah, so the next question is around that. So what are the other benchmarks that we have for OpenShift other than CIS?
So when it comes to security benchmarks, they address many different areas. So controls can be specific for certain environments. Like for example, I think NIST profiles and PCI DSS profiles have controls which address the OpenShift environments as well. So yeah, do we have those benchmarks? Yes and no. So the reason is because Chef has a policy as code approach. We do have a bunch of Kubernetes resources, cloud resources, and so on, which we can use to build out profiles. We have a really good baseline. So for us to build out profiles, which are security profiles, which are very specific to OpenShift, from your and build out, let's say, a PCI DSS profile would be pretty straightforward. So we do have the resources right now. We do have the CIS profile for OpenShift, but to build other profiles, yeah, we will be able to build those going into the future. Yes.
Great. Yeah, so again, around the same subject, like you mentioned Kubernetes, right? If anyone is interested, we did a webinar on KSPM. You can find the recording on demand on our website in case you're interested. Right. Yeah, so take another question. Can these Chef capabilities extend to other container tech, like you mentioned, Amazon, EKS, etc.?
Yes. So I think, Cam, you already mentioned we had done a webinar for KSPM. The technology which underlies our OpenShift security capabilities is the same, which we use for our Kubernetes environments also. And because of this, it extends to many other container technologies, whether it be your managed Kubernetes offerings like EKS, GKE, or whether it be like even Docker environments, checking the compliance state of your Docker host. Yeah, we'll be able to assess all that with the same underlying technology, and it falls under our cloud security offering from Chef.
Right. I think that should be the end of this webinar. Thank you for joining us, everyone.
Thanks, everyone. Have a good day.